identify where it's defined, then expand and simplify. So this has two instructions for us to do. Defined, we have to say, where is it possible? What's the domain? What values for the variable work? Expand and simplify. The word expand means get rid of all the brackets. Simplify means put together your like terms, your like radicals, put it in lowest terms. So we've got some work to do on these. Starting with A. Let's start with the defined part. Do we have square roots? Yes. Do we have a variable inside the square root? Yes. What can't we square root? We can't square root negatives. Does it make sense that the b values have to then be bigger than or equal to 0 to make sure you don't have a negative inside that square root? I'm going to draw my arrows here. This, and this, and this, and this. So first, 7 times 3, 21. 7 times negative 5 root b. How do you multiply radicals? You multiply the numbers. So I have a 7 and a minus 5. That's going to make negative 35. I only have the one radical, so it just is still there. Because I don't have any other radical to multiply, but it would just stay there. So I get negative 35 root b. On the inside, I'd have 2 times 3, which would be plus 6. And then the radical is just one of them, so it just would stay there. And then finally, 2 times negative 5 is negative 10. And root b times root b would be root b squared. And root b squared is the absolute value of b. However, it's already defined to be positive. So technically, you would not need the absolute value bars there, because it's already a positive number. Do we have any like terms? We do in the middle. So I have 21 minus 29 root b's minus 10b. None of those are like terms. The square root is in its lowest form as a mixed radical, so we are done. And if you're going to make a mistake, it's going to happen in B. I'm going to write, there's a minus sign there. That minus sign causes all sorts of problems. So be careful with that. What I'm going to do is I am going to put a big set of blue brackets around this one, and a big set of blue brackets around this one. You have that whole first thing minus the whole second. We have to be careful with that, because that means you're subtracting everything that's in the second one. So we're going to simplify inside those blue brackets as much as possible first, and worry about that subtracting at the very, very end. So what does that look like? Here's the blue bracket, a big set of blue brackets, minus the other big set of blue brackets. First one. Here, do you notice you have that difference of squares? So we could do the shortcut, which says it's just going to be the first one squared minus the second one squared. Says it's a difference of squares. If you want, you can FOIL it out as well, and it would work perfectly the same. Your outside and inside would just cancel out as like terms. The second one, if you're squaring a binomial, I actually like rewriting it first. Root x plus 5 root y, root x plus 5 root y. It's not a difference of squares, so I need to distribute and multiply everything out. See? I'm going to simplify inside these brackets as much as I can, and then I'm going to worry about the subtracting factor. So first of all, if I square this, I'm going to get 9x. Oh, we totally forgot, even I highlighted it, and I forgot to say where it was defined. just thought of that because I was like, do I need the absolute value here or not? I'm going to just slide this answer out over there. Let's figure out where things are defined here. Do we have square roots? Yes. Do we have variables inside those square roots? Yes. We have a square root of x and a square root of y. And you see that the x values have to be bigger than 0 and the y values have to be bigger than or equal to 0. So then, because x is already positive, I don't need the absolute value bars around this x. And squaring y will just be y. I don't need the absolute value because it's already defined to be bigger than or equal to 0. Here, root x times root x, that will be just x. Root x times, it'll be 5 root xy. Inside will be 5 root. Now you see the y and the x, it's still x. You can write xy or yx. Usually when we multiply, we do them alphabetical. It helps us recognize the like terms quicker. And then finally, 5 times 5 is 25. And root y times root y will be just y. Again, we don't need the absolute value because it's already defined to be positive. Now, I've simplified completely in my first set of blue brackets. There's nothing out in front. Can you see that at this point, those blue brackets are no longer necessary? I could just write 9x minus y, and then I have to subtract. I still have, in this one, I have some like terms. So I could go x. These two together will be 10 root xy's, and then plus 25y. So the most common mistake that happens here is people forget these brackets, and in the next step, they do 9x minus x. Perfect. You get 8x. Nothing wrong yet. But then here they do minus y, and then they add 25y. But that negative out in front gets applied to or distributed to all of them. So that, you have minus y minus 25 is going to be minus 26y. And the minus times the 10 root xy will be minus 10 root xy. No more like terms to combine. The radical is in its simplest form. We are done. We have simplified it completely. All right, so question for practice is 8.